Hello, my name is Jessie Regalado. I am a doctoral candidate from the Department of Education at Liberty University. This presentation is part of the Principles of Human Performance Technology course 732. I will be discussing how human performance technology is applied to aviation training. Human performance technology is the key to bridging the gap between current conditions in aviation training programs to the desired performance. The gap is the inability to train students for ill-structured problems. The desired results is to reduce avoidance of critical incidents and increase flight safety. The intervention being used is done by using science technologies to simulate real-world conditions. Today I will show how human performance technology is changing aviation training programs by using controlled simulated environments, ill-structured problems, and 3D simulated emergency and atypical conditions. Human performance technology in aviation is used to bridge a gap in aviation training programs by providing real-world 3D simulation training environments to train junior pilots, to assist in aviation maintenance, and to engineer aircraft designs. Aviation training programs use virtual reality, augmented, and mixed reality 3D simulations to train junior pilots to fly aircrafts, develop motor skills, and improve performance. It is used to develop tactical decision-making processes and procedures that will reduce mistakes made in real-world incidents. Virtual reality are computer-generated impressions of the real world. These impressions are lifelike virtual worlds which are used to navigate and interact with. These computer-generated impressions are used with data gloves, laser pointers, head-mounted displays, or joystick controllers. In aviation, it is used to create weather-related simulations to train junior pilots on simulations that otherwise would be impossible to train. Augmented reality is an application that allows a person to view real-world environments that have virtual objects. These objects can be 3D or 2D images. They can have videos, sound bites, hyperlinks, or information data superimposed over these objects. These augmented reality objects could be on a Google map. Take, for instance, H for hospital or H for hotel on a map. When you click on it, it can have the address or a hyperlink to their actual website. Mixed reality is a blended environment of physical and virtual worlds. Mixed reality blends simulated and digital processes into a physical space. Mixed reality uses human-in-the-loop and hardware-in-the-loop systems with artificial intelligence processes to create blended environments. In the University of Zagreb, Croatia, they used human-in-the-loop and hardware-in-the-loop to evaluate the airplane's design and to modify the airplane before fabrication. You may be asking yourself, what is human performance technology? Is it teaching students how to perform tasks using technology? Is it training technology to perform and think like a human? Well, in the next couple of slides, we're going to go over exactly what human performance technology is and how it applies to aviation training. Human performance technology is an evidence-based method used to discover, analyze, design, develop, implement, and evaluate a human performance gap to bring about a desired result. It is a process of uncovering and examining deficiencies in performance. It is a linear, systemic approach that stresses value over cost, return on investment, and proven productivity and worthy performance. It goes hand in hand with the instructional design ideologies found in ADDIE, the linear systemic approach used by instructional designers to analyze, design, develop, implement, and evaluate instructions. Human performance technology is a doctrine originating from theories in human resource development that assist in facilitating organizational change and improvement. It is inspired by the field of psychology, economics, technology, organizational development, and other learned societies and professional domains. It is used to measure the quality, quantity, and cost of performance. Human performance technology focuses on improving human performance. It uses a multifaceted approach that focuses on results, solutions, value, and sustainability. This is accomplished by demonstrating organizational sensitivity that focuses on the quality of education by reimagining how we study, how we teach, and what we teach with. Human performance technology methods assist the aviation industry to design effective systems and new educational technologies. This is achieved by virtual, augmented, and mixed reality 3D simulations that employ bodily kinetics, visual spatial cues, sounds to help students learn. Human performance technology in aviation considers the heart and soul of the organization when they employ 3D simulations that use bodily kinetics, visual spatial cues, and sound to assist students learn by developing control systems or frameworks that engineer worthy performance. Human performance technology methodologies are applied in education using several techniques, including activity theory, constructivist learning, situated cognition, and Gardner's multiple intelligence theory. Human performance technology, when applied to educational technologies, comes out of the need to integrate science technologies in the classroom. This idea comes to us from educational psychologists that feel that web-based activities, technology literacy, and computer-based education is crucial for constructing cognitive schemas and knowledge. Activity theory is a framework that focuses on the constructivist learning environment. It is used for the creation and the development of object-oriented activities, such as 3D simulations. It centers on human activities and the human mind in relation to the environmental context. In education, object-oriented activities are applied to solve significant computational problems using software, coding, and programming. Constructivist learning theory increases the students' involvement in what they learn, how they learn it, and the pace in which they learn it. Constructivist learning theory promotes self-regulated and self-directed learning. Aviation training methods employ a constructivist approach to train pilots how to fly aircrafts and for pilot selection. Situated cognition is a concept that knowledge is developed and applied by interacting with human beings, their culture, and classroom activities and contexts. It combines class activities and situated context for knowledge building for a real-world design. Situated cognition goes hand in hand with constructivist learning environments in the aviation training because the simulations prepare junior pilots for real-world experiences. Gardner's multiple intelligence theory states that students have 9 distinct intelligences. They are both genetic and experiential: bodily kinetics, existential, interpersonal, intrapersonal, linguistic, logical, mathematical, musical, naturalist, and spatial intelligence. Multiple intelligence can help students be more successful in school and personal life. This is done to create concrete experiences through reflective observation, abstract conceptualization, and active experimentation. Human performance technology in education. Aviation training programs use a constructivist learning environment in conjunction with Kolb's learning styles inventory to create concrete experiences through reflective observations, abstract conceptualization, and active experimentation. This type of environment is a learner-centered environment or active learning environment where learners can work together by actively constructing knowledge and support one another using several tools and resources that support learning goals. Constructivist learning environment is a learner-centered atmosphere that constructs knowledge created by the students rather than communicated by the professor. In aviation training, a constructivist engineering model is utilized to boost point of performance, enhance safety, and increase return on investment. In aviation training, a constructivist learning environment utilizes virtual, augmented, and mixed reality applied to education to evaluate ill-structured problems and to reduce accidents. Kolb's learning style inventory has 4 learning styles: active experimentation, concrete experience, reflective observation, and abstract conceptualization. It is used to align the current state in aviation training programs with the desired state of training. In aviation, it utilizes the Kolb's learning style inventory in conjunction with augmented, virtual, and mixed realities to help junior pilots learn real-world applications. Kolb's learning style inventory is based on the ideology of 6 pedagogical perceptions: that learning is a process based on problem-based learning, adaptation, and interactions with the environment. Kolb believed that students acquire knowledge at different speeds and varied paces. Flight simulators are being used to teach students how to fly aircrafts, to evaluate human readiness levels for emergency flight training in conjunction with psychological tests to screen for vestibular, spatial orientation disorders, and brain injuries. They use intelligent simulating training scenario interfaces to induce ill-structured problems. These simulations are examples of constructivist learning and situated cognition learning styles. Flight simulators are being used as job aids to improve pilot performance in flight training and aircraft design. Flight simulators as job aids are used to update the aircraft's geolocation by using geographic information systems and spatial decision support systems. This concept defines the difference between situational learning and siloed education through motor skills development and tactical decision-making processes and procedures. Geographic information systems and spatial decision support systems use a point of performance to assist junior pilots. These systems geographically coordinate altitude, latitude, and longitude. It offers just-in-time information in action, gives available frameworks for actions, and empowers junior pilots to act or make decisions. Flight simulators operate in combination with physiological monitoring systems to monitor pilot vital signs and to monitor for conditions such as soft pipe syndrome, spatial disorientation, cognition, and mental and physical fatigue. A physiological monitoring system is a health monitoring system that gives real-time feedback on the heart, blood pressure, and brainwave activities. It enhances pilot and crew safety and alerts ground stations if the pilot becomes incapacitated. Human performance improvement is used in aviation to train pilots how to fly aircrafts, how to handle emergency conditions, for pilot selection, and for pilot maintenance. By combining technology with education, students can self-direct and self-regulate their own learning by using augmented, virtual, and mixed reality, authentic simulated environments. Self-directed and self-regulated learning is a process that helps learners construct their own knowledge. It inspires and encourages problem-solving skills. It works well with technology, pedagogy, and simulated environments. Virtual, augmented, and mixed reality facilitate knowledge building by using a constructivist approach to bridge the gap between simulated and real-world activities. In aviation training, human performance technology is used to integrate science technologies such as virtual, augmented, and mixed reality in the classroom to train junior pilots to fly aircrafts. Virtual reality, augmented reality, and mixed reality helps train junior pilots by using an engineering model to assist in aircraft design. It helps them build models that simulate real-world aircrafts to improve speed and takeoff time. Virtual reality is used to build and test aircraft designs and to perform visual inspection training for aviation engineering programs and aircraft maintenance industry. The integration of these science technologies in aviation training support educational practices by scaffolding students, improving performance, and reducing mistakes made in real-world incidents in both the military and commercial pilot training programs. Another example of human performance technology in aviation training is the French Air Force Academy. It identified a problem with their modern onboard instrumentation and found that it caused visual distractions affecting airspeed and visual attention. They used 3D virtual environments to improve airspeed, acquisition, cognitive processes, and visual attention. They found this training to be effective in bringing into line the current state to the desired state of training. The University of Defense in Brno, Czech Republic identified a problem with their curricula and PC-based flight simulators and found that it was not adequately training students for flight missions. The intervention employed was to replace the PC-based flight simulators with 3D simulation software. The switch aligned the current state to the desired state of performance through training and technology. The Technical University of Graz and the University of Darmstadt identified a problem with their flight simulators and found that cost was an issue in adequately preparing students for flight missions. The high cost of flight simulators put stress on the ability to adequately train students. They replaced the high cost of flight simulators with 3D virtual reality simulators for return on investment and full flight instrument training. The University of Zagreb, Croatia, identified a problem with their airplane design and found that there were issues in the aircraft takeoff time and flight time. They evaluated the current state of the aircraft design, then used a constructivist learning approach to modify the aircraft before fabrication, using human-in-the-loop and hardware-in-the-loop virtual simulations. This was done to bring the current model to the desired state by using science, math, technology, and engineering. The Carleton University in Ottawa, Canada, identified 3 problems with pilots 50 years of age and older: flight safety, cognitive health, and pilot safety, and 2 needs. One, to retain geriatric pilots as teachers. The second need is to recruit young pilots. They used virtual reality to screen for cognitive impairment of geriatric pilots and to address pilot shortage by using the How People Learn framework to develop a train-the-trainer program to train junior pilots. The How People Learn framework involves how simulations affect the brain and mind experience. It has 4 lenses: the learner, assessment, knowledge, and community-centered perspectives. The Carleton University in Ottawa, Canada, used virtual reality in the How People Learn framework to develop a train-the-trainer program using geriatric pilots to train junior pilots. It is how they assessed for cognitive impairment as well. In this particular example, the China University of Mining and Technology recognized the problem with fire safety on aircrafts. They realized that they had to effectively train personnel for fire safety in emergencies. They used a structure behavior function model to create a continuing education course using artificial intelligence and virtual reality to address fire safety training. The structure behavior function model is a subjective and experience-based procedure used to describe critical theories of function and behavior. The structure behavior function model is used in conjunction with artificial intelligence and virtual reality. It is used to design instructions based on function, behavior, and structure. The China University of Mining and Technology used the structure, behavior, function model to create a continuing education course using artificial intelligence and virtual reality to address fire safety training in aviation. In this example of human performance technology and aviation training, the Technical University of Cossai recognized a problem with their students on the air traffic control sector. They used virtual reality and augmented reality to train future air traffic control officers how to design and adapt flight routes. This was achieved using virtual reality and augmented reality technologies, as well as educational training courses addressing traffic control and airspace. Kent State University and Dankook University used virtual reality, augmented reality, and mixed reality simulations to combine egocentric and allocentric pilot viewpoints to increase procedural memory, spatial perception, and qualitative judgment. This was achieved by combining the egocentric and allocentric pilot views in simulated environments to bridge the gap between the current state, single pilot view, to the desired state, dual pilot view. Egocentric viewpoints are used in aviation training as a framework for scene recognition. It is used in aviation training as an intrinsic frame of reference. It is used in conjunction with virtual reality, augmented reality, and mixed reality simulations to help the observer recognize scenes based on the intrinsic direction of the scene and the observer's direction. Kent State University and Dankook University used virtual reality, augmented reality, and mixed reality simulations to combine egocentric and allocentric pilot viewpoints to increase procedural memory, spatial perception, and qualitative judgment. Allocentric viewpoints are used in aviation training as a framework for spatial recall. It is used to recall locations such as landmarks for spatial cognition. It is used in conjunction with virtual reality, augmented reality, and mixed reality simulations to help the observer recognize scenes based on landmarks and other features in the observer's direction to form an allocentric spatial representation. In this example, the United States Naval Institute recognized a problem with their computer-assisted instruction and scheduled training time for junior pilots for coursework and cockpit training. They used virtual reality with a 360-degree capability headset to train junior pilots using just-in-time learning and performance support tools for educational training programs and cockpit training, providing virtual reality, augmented reality, and mixed reality simulations and artificial intelligence to be adequate forms of aviation training. Flight simulation training devices are approved by the Aviation Safety Agency for certification and qualifications, and safety training by the United States Air Force. These programs are certified for basic instrument training, navigation, and full flight procedures. Therefore, virtual reality, augmented reality, and mixed reality simulations are considered alternative educational delivery modes in aviation training. Flight simulated training programs are being explored for their worth, their software design, automations, intelligent information integration, whether they enhance performance and prepare junior pilots for real-world activities. Flight simulated training programs are being explored for return on investment. These simulators can cost millions of dollars, so therefore they must align with the organization's mission, strategy, and goals and engineer worthy performance. Flight simulated training programs are achieved by exposing learners to flight simulated controlled turbulent, emergency, and abnormal conditions. It shows that augmented reality, virtual reality, and mixed reality changes educational practices and supports learning. By putting these students in simulated controlled turbulent environments and atypical conditions, it prepares them for real-world scenarios and builds their confidence. Flight simulated training devices are approved by the Aviation Safety Agency for certification qualifications and safety training by the United States Armed Forces. These programs are certified for basic instrument training, navigations, and for full flight procedures. Therefore, virtual reality, augmented reality, and mixed reality simulations are considered alternative educational delivery modes. This is what a virtual reality flight simulator looks like. It is used to prepare, train, and test junior pilot performance by immersing them in a virtual reality environment, simulating real-world experiences. This allows them to practice atypical situations ahead of time to improve pass rates and reduce accidents and incidents. As you can see on the right, the junior pilot is practicing flight routines and procedures, and the avatar on the left is emulating the junior pilot's performance. This is another example of a flight simulator cockpit with built-in flight simulations. It helps junior pilots learn procedures and how to properly perform them before actual performance. It is an immersive virtual reality training tool with built-in capabilities to improve pilot confidence. An electromyography is a physiological monitoring system that evaluates and records electrical activity made by the skeletal muscles. It assesses the health of the muscles and the nervous cells that control them. These nerve cells are known as motor neurons. It measures the speed and strength of the signals traveling between the muscles and the nerve cells. It uses electrodes to translate the signals into values that can be interpreted. This is done to measure for pilot incapacitation. The cockpit contains an instrument panel very similar to a car dashboard. It contains flight controls, pilot seats, rudder pedals, overhead panel, side consoles, flight control unit, heading bug knob, altitude bug knob, pedals, flap levers, parking brake lever, throttle, and flight stick. This is a video inside of United's Flight Training Simulator. Each simulator costs $20 million. They have 31 simulators in their training hub. All the United airline pilots must train on these machines before they can fly the aircrafts for the United Airlines. They must do also continuing education courses on the simulator every 9 months. For those of you that want to try flying at home, there are realistic flight simulators for your PC, such as the Panel A320 Desktop Captain that looks and behaves like a real cockpit with live flight simulators. There are also different kinds of simulators that aren't as real looking, but the video games, I play them. The X-Plane one is really good, and you actually are in a cockpit and you're flying an airplane. I didn't do so good. I crashed a couple of times, so just be thankful that I'm not going to be a pilot. This is the X-Plane 10 Flight Simulator video game. The iPad has the original X-Plane for free, as well as other flight simulated video games for free, and some that you purchase from 99 cents to $35. I read about X-Plane on one of the peer-reviewed articles I read for this project and decided to play the video game to see if any transfer of learning could occur and whether I could build confidence. Like I said in my earlier video, I did not do so well, but I did finally get the plane off of the ground and in the air, and but the landing didn't go so well. But each time that I played, I did get better. So the video game does its job. It does teach, and it does build confidence, and there is transfer learning that occurs. Thank you very much for watching this educational video on how human performance technology is applied to aviation training and how human performance technology is used to bridge the gap between current conditions in aviation training programs to the desired performance, such as the ability to train students for ill-structured problems to the desired result, which is to avoid critical incidents and increase flight safety. By using science technologies to simulate real-world conditions and by employing virtual, augmented, and mixed realities.